prove that the limit as x approaches a of c is equal to c for any fixed real number c. So basically we're just being asked to show that the limit of a constant function is just the value of the constant function. It doesn't matter what a is. Otherwise they would have given us information. Okay, now since they asked for prove, we should probably use our epsilon delta proofs. So let's remember, what do they look like? So for any epsilon greater than 0, we need a delta greater than 0. So that as long as x is close enough to a, then that implies that our function is close enough to its limit. In this case, c minus c in absolute value needs to be less than epsilon. Now, if you're wondering where to begin, and this is something that sometimes happens to people, you're saying, well, there's no x's in here, what am I going to do? How can I take my x values and translate them, move them, parlay them into a result over here? Well, you don't have to. Okay? Notice that epsilon is always greater than 0, and c minus c is just 0. So you're being asked to show that 0 is less than epsilon, or that epsilon is greater than 0. And that's always true. Who cares what x is? Okay? So we just go through the motions. It doesn't really matter what it is, but you should at least distinguish some epsilon, or some delta based on your epsilon. So here's our formal proof. Let epsilon greater than 0 be arbitrary. Okay. You can't just pick some values of epsilon and show it works. You got to show it for all epsilons, regardless of what exactly they are. Okay. We'll claim delta equals 1. Doesn't really matter what. I mean, pick your favorite number. Delta equals 1800. So that'll work. Okay. So we've got to now show that that sort of delta will work. So suppose x minus a is less than this delta. Okay. And now we just leave the x's and the deltas alone. They're really irrelevant. And sometimes people have a hard time with that. No, you've got to use this statement somehow. No, you don't. Okay? We just need a conclusion. And if you know the conclusion's always true, it doesn't really matter what you start with. Okay, so what we're going to do is we're going to say, since epsilon is positive, we see that c minus c in absolute value is just absolute value of 0, which is less than epsilon. And that's what we needed to do. So that's it. Proof over. Okay? It really had nothing to do with the deltas, the x's. Okay? The limit of a constant function is just that value. One of the easier epsilon delta proofs, because you basically do nothing. And yet some people still have trouble with it. Okay? Especially people who are still figuring out the nuances between epsilons and deltas and what needs to be said, what needs to be calculated. But this one's a freebie. It has nothing to do with x, nothing to do with delta. The conclusion is already there.